is Anaid, and I'm going to talk to you about this project about the magnetism. So first we have the research question that was what happened to the magnetism of a magnet when it breaks. Does it stay at the same, decrease, or increase? About our objectives was know if the magnetism of a magnet is altered when it breaks, explain how magnetism is distributed when it breaks, and with the help of a beer cup we measure its attractive properties. And the hypothesis was if a magnet breaks, then each part retains magnet properties, but to a lesser extent, since its magnetism is distributed performing new north and south. So we have four justifications that are contribution to scientific knowledge, contribution to knowledge in other areas as technology, mechanicals, medicines, because sometimes we use them a lot on these areas, and it's important to know the specific measure to don't have like problems using them. Also, it has contribution to the knowledge of college because it's important to students know about these topics, and it's also sustainable and ethical approach because we can help to a lot of people to know more about this topic. So this project seeks to analyze the magnet properties of a magnet and how they perform in environment because it's important to know exactly what happens to a magnet in different situations, which is why the project analyzes the behavior of distance of attraction of magnet when it is divided. So the materials that I used was a magnet easy to break, a beer cup that is the object that will be attracted by the magnet, a tape measure or a ruler, and something to take notes. The dependent variable is the magnet volume, and the independent variable is the magnet's attraction distance. So the first step was measure the volume of this object using this formula with the radius of the magnet and using P. At the second step, I put the beer cup close to the magnet and I started to pull it until it felt on the magnetic camp, and with the help of the ruler I determined that the distance of beer cup attraction was 8.5. At step 4 I broke the magnet with the help of a hammer, and at step 5 I measured the volume of this new piece, and then I repeat the step 2 and 3, and I could measure the distance of attraction of the piece number 1, where I determined that the distance of attraction of the beer cup was 6 centimeters. Then I repeated these steps with a second piece to be sure that the experiment was correct. So I decided to recollect all this information in a form of table because I think it's easier to analyze the information when it's put like that because it's more easy to see. Here we have the volume and the distance of the beer cup attraction with a magnet, the piece number 1 and the piece number 2. So based on the experiment, we could notice that the distance of attraction of the magnet when it fragmented, yes, it reduced around 2 centimeters. Since the second test, the object was no longer attracted by the smaller piece, and I had to put it like closer to the magnet so it started to move. So yes, we can say that my hypothesis was correct, and this changed when a magnet breaks. In conclusion, these experiments allowed us to demonstrate that it's important to monitor the state of a magnet before use, because tests of this style can be applied and even rely on the laws of physics for better results. Although the experiment was able to answer the question that we made first, and it could have been done more precisely using different tools, but in this case what we wanted to do was make this experiment in the easier way possible. But in other case we could use something different to measure the magnetism, so we could get more specific. The limitation of this experiment may only apply to bodies with permanent magnetism. The factors that could negatively influence could be temperature, where the magnet breaks, composition. So some risks are accidents, careless handling, and do not be careful with possible impacts from the beer cup being attracted by the magnet. Um, the science is the explanation of the basis of everything that we know. So it helps to give us a logical explanation. Using the scientific method give us the power to speak with certain about what we know, and the scientific method allows to us to be informed with facts and not assumptions. So during this activity, I understood how a magnet field works and its distribution along a magnet. This activity taught me to investigate and experiment when I have any doubt, and investigated about many processes that I did not know required a magnet. And this project supports the idea of physics where any question can have a logical answer, and it's necessary to experiment.